I work with AHF analyzing technique. We have been doing Argolight solutions in Europe for quite a while now, and we've just started to do this in the UK and Ireland. So I'm not completely off there, but let's go through this. So AHF provides a range of solutions for microscopy: LEDs, light engines, filters, things like beam splitters, R&D setups. Like this is the Tune Cube. Also tissue diagnostics, image analysis, scanning platform. And we also do service. So if anyone buys filters from us, we actually fit the filters in the cubes. We can also test filters and test them for transmission and damage and things like that. So as part of the product range from AHF, we have the Argolight products, which is a kind of Swiss Army knife fluorescence QC. So as you see, we have a range of products here. So we have on the quality control slides, there's an Argo Power, which is a high magnification slide, which is linked to a power meter. So you can do power measurements alongside the patterns. We have the HM slide itself, which is a range of patterns for high magnification. Also a low magnification slide, and a slide called SIM, which is for super resolution and structured illumination. There are more basic slides, which are called Argo Check, where you can check the homogeneity, the resolution and intensity, and they've just got a reduced number of patterns. In terms of the software, there's Daybook and there's Analysis and Data Manager. Analysis is free and is downloadable, and you can analyze all of your patterns for free. The Data Manager is a kind of paying subscription setup where you can put in all of your results and you can check parameters as it goes. So if you take results from the first week and then take them from the second week, you can check, you can compare, you can set parameters which flags if there's anything wrong. I won't have time to go through Data Manager today, but I can answer questions on it later. This is a little bit wordy, but why is quality control important in fluorescence microscopy? There's a move from qualitative to quantitative microscopy. This is something that's come in with things like super resolution and fluorescence intensity measurements. People want to know the figures. You need to ensure that your microscope is performing correctly, either day to day or over a period of time, to check whether your experiments are giving the correct results. There's an increasing complexity of machinery. So it used to be basic microscope fluorescence lamp, and that was it. And now there's turf, now there's lasers, confocal, everything added together. And the more complexity you get, the more possibility you have of error or misalignment on your setup. Also, there's no official standards for fluorescence microscopy, although there are protocols, and protocols are used institution-wide for this is how you do this particular experiment. For example, in clinical, if you're doing immunology, there's a protocol, how you set the microscope up, what test slides you're using, what intensity you use, etc. But that's difficult to expand to a kind of general setup. Also, someone might bring a slide and say, my slide's not working. Is it the microscope? Is it my sample? So this is something you can check. Troubleshooting immediate issues. You might get a loss of intensity from a light source, or you might get some kind of, maybe you've got damage on the lens or something like that. Maintenance and tracking of parameters in a proactive way. It's different to troubleshooting. This is my system working well today? Is it working the same next week? Is it working the same next month? So it's a kind of way of a check when you're not under a stress situation. You're just checking things moving along. Provide assurance for data for publication and reproducibility. A lot more people now, when they produce a paper, they produce an image of the slide, and maybe Alex's slide or an Argo slide, saying that we have tested this and this is the results we've got as part of the paper, and ensuring that the data is robust as well by continuously checking that the microscope is working in the correct way. You can also use test service reports on installation, that you've got the correct homogeneity, you've got no issues, and you can produce reports like a PDF that you can give to customers. And another issue is possibly things like microscopy training, where you're educating people about microscopy. You know, what does a PSF mean? How does it work? What's the difference between super resolution and something else? So you can use these slides as a kind of educational tool. Alex mentioned Quarep Limi, which is a group of working groups, around about 9 at the moment, I think, with about 266 members. AHF are on there as well, and I think Argolight are for different research groups. And these are initiatives to try to produce some kind of standard in fluorescence microscopy, and there aren't any. There is an ISO 21073, which was produced to try and produce the different parameters required for consistency in confocal microscopy. Obviously, that's difficult because you have different methods of producing your confocal microscopy, different methods of detection, different cameras and PMTs and all other ways of doing it. So it's a very difficult thing, but it's an attempt, and I think that's part of the thing that people are trying to do now. They're working towards. So the Argolight products, similar to Alex's, there's a series of patterns. The slides are patterns of inorganic fluorescent material etched into the slide. They're very high precision. If you go to the Argolight website, all of these are highly defined as to what they are, what their measurements are. Another crucial thing is all of the patterns are 170 microns into the slide, and this mimics the cover slip. And the cover slip, there is an ISO for cover slip called A2551, which kind of recommends the thickness and the refractive index of the glass used for cover slips. The slides are oil, dry, and water suitable. There are conditions in terms of how the slides are used, and this is all outlined in any user guide that you get from Argolight. So these are some of the patterns, and some are similar to the previous talk, but some are slightly different. So on the left here, you have a target, and this can be used as a very basic target for things like power focality and power centricity, but also for alignment of camera with a stage for scanning applications. Also used for rotational problems in a microscope if it's been knocked or something like that. Second one is what looks like a set of dots across a field, which is obviously used for field homogeneity. If you zoom in, it's actually a set of rings, and these can be used. You can see, or you can maybe see that there's some kind of distortion on the rings, so they can also be used for higher power distortions. So these are intensity squares, and they're kind of they're set of like grid lines, which are used for a few measurements, and you can tell by sets of line profiles going across them in the measurements. This is you can see from here that it's kind of going in Z, but these are also fluorescence intensity measurements where it might be more appropriate to use this as your intensity measurements rather than the other squares. So it depends on your setup. There are also different sizes. So depending on the slide, the high magnification slides and the low magnification slides might have the same pattern, but different measurements, obviously. And this is a set of stairs. These are highly accurate patterns, 4 different patterns with different step sizes. So they look a bit like this. So you can see that they move into the sample and they also have different sizes and different step differences, so you can really test the Z system. Also useful for things like if you've got a motorized stage and you have drift on the stage, you can test if the focus moves a couple of points along the stairs. There's a series of crosses, just look like simple crosses, but actually the vertical lines are in plane, but the horizontal lines move in different levels of Z. So again, you can test actual resolution using this.
Just 1 more minute, Peter, if that's okay.
1 more minute. Okay,
yeah, we're running out of time for this session now.
Well, let me go through this fairly quickly then.
Okay, so, no worries.
Okay, so there's an orthogonal view here of 3 circles, and it's to test reconstruction of circles, so depth and 3D reconstruction on focals or Z systems. This is another set of rings, but it's got a pattern underneath at a depth, so you can test your structured illumination and super resolution systems. So this is an example report, and this is a type of data you get. So you get heat maps, you get graphs, and you get physical data, which you can export as CSV or PDF. Simple application example is difference between wide field decon and SIM. Here you can see this was produced by the Salk Institute. You can see the different line profiles, and it really is just proving a setup. So in this case, is the SIM better than the decon? Yes. So a quick run through the software if we have time. Here you have launch analysis, launch a data manager. I haven't got time for the data manager. You can choose your product type on your slide. So here you have, is it a power, is it HM, is it LM? And this will influence the results produced by the analysis. So we get this screen, select an analysis, and then we can upload files. So we upload this field of rings. On the right side, we get data, metadata. At the bottom, we have a required pattern. So for this particular image analysis, we need this particular pattern. If you use the wrong pattern, then it warns you, so it keeps you going in the right way. So when you've selected your image, you can crop it, and here it suggests on the left how to do this. So you crop your image, and you get a single field, a single ring here, and this is the image. This is the analysis that's produced. So you can see your primary metrics. There's also secondary metrics, algorithm metadata to do with your microscope, etc., produced here. And then you can generate a report. It didn't work when I did it, but if I clicked on this before I showed you the PDF. So I'll leave that for now. And then a new addition to the analysis software, PSF. Alex mentioned that PSF's importance. We can analyze a PSF. We don't have a structure for doing this in the slide, but you can upload external beads, anything you have that will work, and it will generate your PSF report. And this is new in Datebook 3. So applications, we can troubleshoot straight away or as a continuous measure. We can compare with reference images. We can check with physical things like, is your camera aligned properly? And there's lots of field of view issues like distortions, homogeneity. And this is also useful for example, checking lenses. So you can check whether, like Remus was saying before, you have a apochromat and acrochromat, and all the rest of it. You can check how they differ. So purely for a research thing, if you want. So also intensity changes in light sources. Metal halide often drop off very quickly. You can compare super resolution methods like SIM and confocal. You can check your linearity after deconvolution. I know Huygens have used this for that. And also 3D reconstruction accuracy.